Okay, good morning, good afternoon, good evening, depending on where you are in the world. My name is Don Bowman. My company is Agilicus, and today I'm going to talk about one of my favorite topics, which is risk in operational technology, specifically cyber risk, and more specifically, reducing that risk at a reasonable and pragmatic cost. And one of the things about operational technology and risk is it's not as well served and modeled. There's a lot more people out there telling you what to do with that laptop at the front of the house than there is telling you what to do about that VFD at the back of the house. So our agenda today, we're going to first talk about why it's not IT. There's nothing wrong with IT risk. There's nothing wrong with OT risk. There's nothing wrong with treating them together, but they're not the same. And they are overlapping, and you have to work on both sides in order to achieve your objective. And your objective is to have a reasonable amount of risk. Zero risk is an outrageous objective. It would mean your company is just never going to go anywhere. But also just saying YOLO and accepting infinite risk is not the right thing either. We're going to talk about a specific program that we at Agilicus have developed, a set of cybersecurity best practices designed for this hybrid environment, this company that has an IT and an OT and an overlap shop, and they need to understand what their best practices are. And we're going to talk about 5 specific investment areas, dimensions, each are independent, and why it's important to have independent investment in each of those areas, and why that gives you a pragmatic approach to reducing risk at a reasonable cost, or more accurately, reducing the cost of the risk better than the outcome of just accepting the risk. So here's the thing. I don't know you, but I absolutely know you. Your environment over relies on a concept called the air gap. People speak of it as if it was one of the 10 commandments handed down back in the day, and it's not. It's not to say it's a bad thing. It's not to say it doesn't exist, but it is part of a balanced breakfast. It's part of a defense in depth strategy. It is not the be all and end all. And the reason is it's only one thing, and stuff can get in over the air gap. Want to know how I know? Go watch the Stuxnet documentary and see how Iran, who had a legitimate air gap with guys with guns, have their centrifuges taken down by an adversary that was motivated and skilled. And I'm sure that your adversary is not the same adversary they had, but I'm also sure that there's somebody walking into your building with a USB key that they got at a trade show and about to plug it into that SCADA machine that's been sitting around for a while without the patches. You know the one I'm talking about. So your air gap is only one layer. Your environment is over relying on it, which means you're under protected in the other dimensions. Threats can get in over it. Threats can also bridge weak devices. We saw that at the end of last year and the beginning of this year in both Poland and Romania in the electrical grids, where they were attacked by another strong aggressor, in this case probably Russia, and they were able to get in, get to something, go sideways, get to something, go sideways, and cause some damage. We call that lateral traversal. So it could be as simple as something gets on the guest Wi-Fi, which gets on the building management system, which gets in. But it could also be, like I said, somebody tracks in some code and it gets onto something and that something has more privilege. Risk is an equation. And it sounds like a bad thing. One of the things I had to take in school in my society, technology, and risk course was around the Ford Pinto. And Ford Pinto was a car that is better left forgotten from the malaise era of North American cars, but it was kind of famous for one thing. If you tapped the rear bumper of it in an accident, it would blow up and kill you. So they say. And when they dug into it, it turns out that Ford's engineers knew of this. And they're like, okay, well, we've got the gas tank in a certain location and it's mounting, and it's going to cost $5 extra per Pinto if we lower this risk. And somebody in the accounting department with a sub-minor in actuarial something did the math and said, well, how many Pintos are we going to sell times $5 equals X? Okay, how many accidents occur per year? Okay, how many of those are Pintos? Okay, how many of those are going to sue us? Okay, that's Y. Y is better than X. Okay, don't put the $5 part on. We'll just let a few people die and sue us. It's better. True story. Risk is an equation. It's threat times vulnerability times impact. So your threat is, what bad actor you're against. If you have a really, really strong threat actor here, you're going to have a lot more risk no matter what you do. If your threats are just sort of run-of-the-mill accidents, like somebody accidentally did something, it's going to be an easier time for you. Times your vulnerability. And your vulnerability is the one you have the most control of here. So the vulnerability is how vulnerable are your systems? Are they patched? Do you have firewalls, etc.? And then you multiply that by the impact. So if there's no impact to a cybersecurity outage in your environment, it's a lab setup and we can just re-image the thing and it costs us nothing, you're not going to do anything to manage your risk. If the impact is that everybody who's bought a Ford Pinto is going to get roasted, caught fire, and so on, and that your company's reputation is going to be dragged through the mud in front of Congress, well, you would want to control your vulnerability a lot stronger. Risk is the equation of those three. For every business, there is an appropriate level of risk that you ultimately can accept. Certain threats, certain risks, you just accept them. Certain you insure them, and certain ones you control them. Here today we're talking about control. A lot of people will tell you that if it's got an IP address, it's all the same. And a lot of people will tell you that things at OT have nothing to do with IT and they're completely unrelated. Both of those people are liars. I'm here to tell you the truth. You've got a hybrid environment and it's a little bit of A and a little bit of B and etc. Your IT environment, it's hybrid. You got some people working at home and working away, and you got some stuff in the cloud and you patch frequently. Your operational technology, it's actually none of those things, right? Like, it's not that it's mostly in the cloud, it's in your building. It attaches to stuff. It's not that your people are doing work from home, they're touching it in the plant. And it's got very little SaaS, although that's increasing. In between, you've got a shared infrastructure. Here on my Venn diagram on the right, I've shown a management engineering system and a historian and the overlapping Venn, but you might have other things that are there. But you also, and this is a big subject of today's webinar, you've got stuff that's lurking in the bottom circle that in your mind is deeply embedded snowflakes like a PLC, and there's nothing you can do about it, and there's no way to secure the air gap's the only way. You're wrong. You got a bunch of stuff kicking around in there that supports the process but isn't the process. You're probably running VMware ESXi in there right now. You may run Veeam for backup. You may have a Windows domain controller in there. You got a bunch of stuff in there that's just IT stuff in a different building. And this needs to be treated much more similar to the IT environment. And you don't, because in your mental model, it's inside the air gap, therefore it's an engineered solution. It cannot be modified. It's untouchable. The system integrator that put it together 20 years ago has blessed it, and there's a process document somewhere. That's not true either. The reality is much more nuanced than that. If you want to get that risk equation to go down, you have to face the environment that you're in. You can't just assume. The other thing here is you are underserved. There is a lot more money and a lot more advice going into those IT shops because there's a lot more of them, right? There's just a lot more companies that just have a couple of cubicles and an Exchange server. It's just the way it is. And as a consequence, a lot of the advice you get, other than from me, is wrong. It's not necessarily that they're malicious, but they're selling their product and they're telling you the best practices of how they sell their product. And they're like, okay, just run Windows Update on that PLC every week. And you're like, what are you talking about? I can't have downtime. And also that makes no sense. So you get these overly simplistic, and as a consequence, you tend to shut down. You tend to think, well, because I'm this unique snowflake and those guys don't understand, and I got an air gap anyway, this webinar is not for me. I got a simple solution for you. It's simple. It doesn't mean it's zero work, but it is simple. It's not that complicated to understand. So the first thing is we're going to talk about orthogonal layers, and there's a reason for this. Your air gap is a type of firewall, and you could invest an infinite amount in making that single factor better. You could put a moat around the building. You could put armed guards. You could have, rabid raccoons walking around outside. You could do whatever you like there. But it's only protecting against one direction of risk, which is outside bad, inside good. We're good to go. But it doesn't really protect against, you've got vendors that come in with their own laptops, and you've got supply chain, you've got upgrading software, and you got stuff like that, right? So you got to have more than one dimension. And those dimensions don't overlap with each other. In the airline industry, they use this kind of tortured model called the Swiss cheese model. And the idea is you slice a Swiss cheese and you shuffle the slices and, risks get through one hole, but they can't get through the other holes. And I guess I understand it. It sounds delicious. A good ham and cheese sandwich would be amazing right now. But um, my little diagram on the right, I'm going to talk about these 5 layers in a second, but they're not actually layers. They're independent. And there's a reason they're independent. So one of the best practices out there for security is called multi-factor authentication. We're going to go a little sidebar for a second. So multi-factor authentication, why is it a good thing? Well, multi-factor, it turns out you need at least 2 of something I have, something I am, and something I know. You can't have 2 in the same category or it doesn't give you any protection. And the reason is the risk of one of those getting taken is uncorrelated to the other. So think about that. Something I have, my phone, my YubiKey. Something I am, me, my fingerprint, my face. Something I know, my PIN, my password. So what's the risk that you get a hold of my phone or my YubiKey? Well, I don't know, you rob my house or you steal it from the bus, I leave it on the seat or whatever. It's different than the risk that you get physically hold of me or the risk that I use the same password on different sites. And since those risks are uncorrelated, when you need both of them, it actually reduces more than the individual protections themselves. And that's why when some people tell you, they use 2 things for multi-factor. Okay, you're going to have a password and then we're going to email you a PIN code every login. That's not multi-factor. That's just theater is what that is. It's not even good theater. Good theater would be interesting. This is just irritating. This is irritating theater. So here we're going to talk about 5 orthogonal layers. Each one, and this is the other thing is, the enemy of good enough is perfection. So you want to invest a little bit in each area, but you go into this analysis paralysis. Oh, I got a really hard problem. I got all this stuff back here, and I don't really know how all of it works. And there were a bunch of system integrators and me and manufacturers over the years, and this switch was really hard to get working. We don't want to touch it, and therefore we can't do anything. Okay, let's do nothing, right? Or somebody says, well, it's just such a big problem. I got to make the entire world secure, and you just stare at this thing. But no, I'm here to tell you there's 5 different paths you can work on. You can work on any one of the 5 at a time. You can work on all of the 5 at a time. Every incremental little bit you get better in one of the 5 affects all of them in a positive and nonlinear fashion. Nonlinear being good, in this case, exponential. So we're going to work on that together today. So visualizing 5 dimensions, it's not easy. We all got 1 dimension. It's a line, right? It's the simplest thing we learned in school. We were given our pencil in kindergarten. We drew a line. Number 2 is 2 dimensions. We've got a plane. We got a piece of paper. All right, that's great. Number 3, okay, well, I'm a 3-dimensional person, and I got X, Y, and Z axis here. Number 4, well, a lot of people think about time as that 4th dimension. That's what they used a lot in Star Trek and so on. When we get into the 5th dimension, now you're starting to talk about TV shows from the 60s that were kind of exciting. They were sort of like the Twilight Zone, but maybe a little bit edgier. What does 5 dimensions mean? Well, the idea is that, a line, if you think about your protection as a line, sort of holding a string up and hoping the attacker doesn't get past, the 2 dimensions, you're holding up a sheet of paper and hoping they don't get past. The 3 dimensions, you're putting a cube around yourself and hoping they don't get past. It gets harder, but you see where I'm going here, or hopefully. Risks and correlations. This is one of my favorite. You should watch The Big Short. It's one of my favorite movies. Might even be my favorite movie. I'd have to think about that. The Big Short, they talk about the 2008 financial crisis, and it's funny, but it's black humor at the same time. And one of the things they go through is everybody and their dog bought into these collateralized mortgages. So they took one mortgage and said, well, what's the odds that you default on your mortgage? Okay, let's staple 1,000 of them together. And therefore, it becomes AAA rated, even though individually the people in it are kind of weak. Ninjas, they call them, no income, no jobs. And, people don't default on their mortgages, so therefore this is a safe AAA investment. And then all of the people that didn't really understand risk, and I'm looking at pension funds and municipalities here, they loaded up on this. It was something that gave them a zero risk, higher return than T-bills. So they loaded up on it. They bought thousands and thousands of units of these collateralized debt obligations that were made by a bunch of fraudsters effectively. And then they got the ratings agencies to stamp it with AAA. And their rationale for that was individual mortgages have a high risk, but collectively they don't. But what they didn't really consider is that there were correlated things here. Any downturn in the economy, if one house in a neighborhood doesn't sell, then the next house is much less likely to sell, and the next house is much less likely to sell, etc. And in the movie, they show it with Jenga, and there's a bunch of funny things going on. But the idea there is sound in that those risks were actually correlated. So the risk that your neighbor didn't pay their mortgage if you didn't actually went up. They weren't independent. So you need independent controls of these things to have a happier you. If you think about the risks associated with your environment, you don't want to put all your eggs in the firewall basket. That's the idea of the mortgage thing here. So what are my 5 best practices? I'm going to let you in a little bit of a disappointment. I'm not going to walk you through getting your environment fixed on this webinar. For that, my team's going to reach out to you. You can call us, and I'm going to give you some great assets at the end. You can go to our website. It will show you the best practices. And there's a really handy assessment guide that will give you pragmatic advice. You can fill in what you do today, and it will go through a big mathematical model, and it will show you what you should do. But I'm just going to give you the teaser for this because I've only got a little bit of time. Here's my 5 dimensions. Number 1, boundary. Boundary defense, that's your firewall. So if you think about the human body, that's my skin, right? So coming back to multi-factor, my skin is what keeps the bacteria from killing me, but when my cat bites me, I don't die. It's because I got white blood cells. So boundary defense is moving beyond simple perimeters. It's boundary defenses. Don't think of your environment as outside bad, inside good. Think of it as a set of layers, and each layer has to protect itself from the layer above it. So at the very bottom of the floor, you've got a bunch of sensors, and the sensors go into an Ethernet switch, and they're going to go to PLC. And the sensors, A, shouldn't be able to talk to each other, and B, nothing else in the world should be able to talk to that, even the layer that the PLC's in. And they talk to the PLC. The PLC's got a bunch of stuff that's going on, so there's some controls here and there and everywhere. And it's got some interface up in your SCADA layer and your HMI and so on. And again, it's got a layer there. You don't want the rest of your world getting in and talking Modbus to that thing. It doesn't have a password. So you got a layer there. And then you've got your HMI, and you get some other stuff in that area. And then you got some stuff that supports the process we talked about earlier, VMware, Veeam, all those other things. Each of these layers, and you could think of them as layers, or you could think of them as cubes, or you could think of them as bricks. It doesn't necessarily be hierarchical. You've got, you could have factory line A, B, and C that they should be firewalled from each other so that you don't have cascading failures. Ransomware. You think about somebody like Jaguar Land Rover, it took down their entire universe. They would have been much happier people if it just took down one dealership or something, but no, it took down the entire universe. So you want those boundary defenses between handoffs of zones of responsibility. You can't have an infinite number, like that perfect microsegmentation. That's a false goal. People will tell you that you can get there, but the config cost gets so high. Going back to my equation, risk equals those 3 things, your cost to mitigate that risk is higher than accepting it. The second best practice is identity and credentials. So here, you got to think about, first of all, there's 2 types. There's people and there's systems. They both have identity and credentials. I'm going to talk about people mostly, but it does apply to systems, like system A sends to system B, or system A sends to the cloud. You can't create new ones here. This is a bad concept. I see this a lot, and people say, well, I'll create you an account for me. I work with Siemens. I'll just create the Siemens shared account. There's 300,000 people work with Siemens. You can't be sharing an account there. You can't do that. It's just not done. It's not even hard to let them do single sign-on with their own credentials, even in that OT environment. I know you're telling me I'm going back and I'm giving you the same bad advice. I'm telling you, with my system, you can have single sign-on to an HMI deep inside the plant with multi-factor without your operators coming at you with pitchforks and without introducing new accounts. You got to get identity and credentials solved. The reason is, this was all originally prefaced. We looked through the CISA RVAs, the risk and vulnerability assessments. So when bad things happen to good people, they called in CISA. CISA said, all right, yada, yada, yada. We figured out where it happened, how they did it, blah, 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 kill chain, a bunch of words. At the end of it, these are the problems, and they boiled all that down. Identity and credentials, this is the one, right? So everything gets in this way. Pass the hash, unknown, known password, non-vendor, embedded, this, that, etc. You got to solve this one. So each of these you're investing in. So you're investing in making your boundary defenses better. You're saying more boundaries. You're saying better controls between the boundaries. Identity and credentials, you're investing in making this better. You're doing password vaults so the end users don't know the password of the system that can't have it changed or can't have more than one user. So think about here like Rockwell panel view, runs VNC on Windows CE 6.5, and you're not going to throw it in the garbage. Or maybe the Rockwell vendor would love because they got a new one, but you're not going to do that. So a system like ours can do password stuffing so the end user sees single sign-on, multi-factor, safely use that VNC NIST2 standard. Boom, it stuffs a password in the system, so the system will accept them in. User doesn't know that password, identity and credentials. Third one is lateral movement. It's related to the boundary defenses, but you want to make sure that a compromised device doesn't create a bridge. You don't want it to be able to be used so the attacker gets into A and they go to B and now they're on C. So you want to be able to have controls between devices. This is where the air gap really fails you because the air gap is hyper optimized against outside bad, inside good. It's really terrible about now you're inside while you're good, right? It's all one big broadcast domain. We can all talk Modbus to each other. No, you don't want that. System hardening. This is another area that the air gap people systematically don't look at. They're like, well, I got an air gap, therefore I don't care. No, you need to keep these things up to date. What does up to date mean? Well, it's going to be different based on the things. I propose you put all your equipment into 3 mental categories. Okay, you ready? 3. Number 1, it's just IT equipment in a different building. Get over it. That Exchange server that you use on the shop floor so you can do email there, that domain controller that you put inside the air gap, that ESX server that runs all the VMs that support stuff, that Veeam system that backs it up. You're in denial. This is not somehow an industrial control system with deep Snowflake PLC and blah, blah, blah needs. It's just a server in a rack in a different building. Patch it, keep it up to date. They all have HA methods now, so you can do that without taking the process down, because I know what you're saying, patches take things down. You don't have to. You can upgrade your ESXi and leave it live. There's a way with their vMotion to move your VMs between the blades and upgrade the blades and have dual controllers. You can do the same with all your Cisco switches and so on. You run OSPF, ECMP, all these tools. They exist. You should start investing in them. That's category 1. It's IT stuff in a different building. Treat it like your IT stuff. Keep it up to date. The second one's a little bit harder. This is IT stuff in a different building, but it directly supports the process. So I think your SCADA historian here, right? It can't be down. It doesn't run the real-time control system, but you can't have it down. You have to be able to report this stuff. You're going to have to keep it up to date, but you're going to have to do that in some balance between auto updates on Patch Tuesday, which is clearly not in your interest, versus, well, every leap year of a century, but not of a 400 years I do it, which is sort of what a lot of you are doing now. So you're going to have to do some work there. This might involve investing in a testing environment so you can test out your change. This might involve testing some HA or some availability methods so you can upgrade it live. And the third category is where it really gets hard. And this is the process. This is something where, patches get really thin when you start talking about industrial equipment. It's not like there is a big CVE catalog and a Patch Tuesday Windows Update server for Rockwell PLC. It doesn't really exist. But you do need to do some work on those, but you also work on what's called hardening measures there instead. So the hardening measures or mitigating measures, it may be specific firewalls or blocking all the ports or turning off the services you don't need. And that's really where you focus more on the system hardening here. So system hardening is a combination of disabling services you don't need, turning off default passwords, changing default credentials, locking it for the mode you're in, creating a baseline so you make sure all your systems are following it so it doesn't drift away, and also keeping it fresh. And the last one's visibility and detection. You want to know, you want to see. One of the things about defense in depth is you're trying to buy yourself some time to react. So if all you have is a single layer air gap, that one piece of paper, 2-dimensional I'm holding in front of my face, from your standpoint, the world is good until instantly the world is infinitely bad. But when you have defense in depth, you've got like a castle and a moat, and you can see them coming over the plains, and then they're struggling through the water, and you've got leeches in the water, and then boiling oil, and you're falling back to the keep. You're seeing that happening. So in this environment, investing in a SIM, investing in centralized logging, investing in maybe firewalls that give you deep packet inspection telemetry and so on. This lets you see that somebody's in and probing and trying to find. Time is something that is very precious for you when something bad happens. Buying yourself minutes, hours, or days is dramatically cheaper um, than the outcome. Like if you have 0 seconds to react, what are you going to do? So next steps, I've talked my little talk and I've explained that there are ways you can de-risk your operational technology. It doesn't have to be an all or nothing forklift of everything. It doesn't mean that the air gap is infinitely bad, just like it's not infinitely good. I've suggested 5 different areas. Each one you can invest a little bit every day in, and each one that you do a little bit better, it makes all of them better because of the holes in the Swiss cheese not lining up. I've suggested you watch The Big Short. You should go watch it tonight. It's a great movie. Um, what are your next steps? I got 2 tools for you here. The first is our self-assessment guide. Um, this is free. Doesn't even ask for your email. You can just go onto our website right there, and it's going to ask you. It's a fairly detailed thing. It's not going to be like 1 second, yes or no, green light, red light. You don't want that. I'll just give you a red light to tell you to buy my product. But what this will do instead is it will assess each of those 5 dimensions, how you currently treat them, and it's going to give you some very pragmatic advice as to what we think you should do next to help you align with the best practices of the industry, to help you reduce the risks of those materialized risk and vulnerability assessments that CISA did, and to reduce your risk at a pragmatic cost. So this is an absolute simple thing for you to do. And then the second thing that's a related document, and you could use it first if you want, is we have a much more detailed best practices guide. It explains in more detail what I just went through, why there's these 5 dimensions, how they don't relate to each other, how it could mean for certain equipment, and what we think the best practices are for you, my viewer. With that, again, my name is Don Bowman. My company is Agilicus. You can reach out to me, don@agilicus.com. Thank you so much for your time today. I hope that this was somewhat entertaining as well as somewhat useful. And I believe there's a way that we can de-risk operational technology at a reasonable cost and a reasonable impact together. Remember, risk is that equation. Risk equals threat times vulnerability times impact. You don't have a lot of control on impact. You don't have a lot of control on threat. So let's work on the vulnerability together. Thank you so much and have a great day.